there's just a couple of questions here on the Jamboard that I will do the solutions to before your test tomorrow. So I'm just going to go over page 344, number 6. This one says, a parallelogram has its sides determined by the vectors OA and OB. So we know two sides of that parallelogram. We're starting from the origin. That the origin would be one of the corners or vertices of the parallelogram. And A and B, these points here, would be two of the other vertices. So what we need to do is figure out this fourth point on the parallelogram. And we can kind of do this using the parallelogram rule of vector addition. So this, if I'm going to call it C, this resultant, and I'll just kind of draw that through, the resultant OC would equal OA plus OB. Because this vector OB, if I color code that, is going to be the same as the top. Because it's a parallelogram, they're parallel and equal in length, so those would be equal vectors. So we can then figure out that OC is going to be equal to OA, which is 3, 2, negative 6, plus OB, negative 6, 6, negative 2. Kind of drawing the rest of my parallelogram. So OC is negative 3, 8, negative 8. So that's this point. C is negative 3, 8, negative 8, or the vector from the origin to that point. So that's one of the diagonals. And the other diagonal, I'll color code this in differently here, would be vector AB. So vector AB, or you could do BA just as easily, will be from point B, which is negative 6, 6, 2, going from point A. So 3, 2, negative 6. So the ending minus the starting point. So for the X, I've got negative 6 minus 3, so negative 9. For the Y's, I have 6 minus 2, which is 4. And, no bracket yet. And for the Z's, I have 2 minus negative 6, which is positive 8. So those are the diagonals of the parallelogram. AB are AB and OC with those points, with those vectors shown that we found. The next part has us looking at the angles between the sides of the parallelogram. So if we have, let's say, O, A, B, and C like that, I want to find the angles between the sides. I'm just going to pretty arbitrarily find this angle here. Now, we know that the other angle would be 180 minus theta, because that second angle will form a C pattern, like what we did when we were doing like the adding vectors, that we would have a C pattern there. I really only need to find one of the angles, and then I know that the other angle would add up to 180. So whichever one I find, I can subtract from 180. So what I'm going to do, to find angles, we really do need to know stuff about a triangle. So I'm going to ignore point C for now. And I'm just going to look at this triangle to find theta. So I know that this is vector OA, and that would be that magnitude. This side is the magnitude of AB, and this side is the magnitude of OB. Now I am going to possibly run a little bit short on space here, so I'm just going to try and find myself some more room. and find those magnitudes up here. So the magnitude of OA is going to be the square root of 3 squared plus 2 squared plus negative 6 squared. So the magnitude of OA is, it actually is square root of 49, so just 7. And then the magnitude of OB is going to be the square root of negative 6 squared plus 6 squared plus 2 squared. And that is root 76. And then the magnitude of that other vector, AB, which we found, will be the square root of negative 9 squared plus 4 squared plus 8 squared. So that is the square root of 161. So now we have a triangle where we know all of the lengths of the sides, and I'm just going to use the cosine law here. So I know that the magnitude of AB squared is the magnitude of OA squared plus the magnitude of OB squared minus 2 times the magnitude of OA times the magnitude of OB times cos theta. So rearranging this, I'm going to get cos theta equals, now the magnitude of OA squared is 7 squared. The magnitude of OB is root 76 squared. And then minus, kind of rearranging that cosine law, the square root of 161 squared over 2 times 7 times root 76. So that's a little bit squeezed in and kind of skipping some steps in rearranging the cosine law, but I trust you guys to figure that one out, or kind of show a bit more steps if you need. Now, taking a look, if I do all of that work on my calculator, I get that theta is 107.16 degrees. So that's one of the angles between the two sides, and the other angle you would just subtract from 180. So it'd be like 72 point something degrees. So there is one comment here. What's the reason I can't use vector OA plus the magnitude of OA plus OB instead of OA minus OB? So you absolutely could, if you used the magnitude of the OA plus OB, that would be just going to kind of highlight this here and kind of make a mess, but hopefully you guys would understand if you're watching the video. If you did that, you would be finding this triangle, so the OA plus OB, and you'd be finding a different angle. So you would be finding the other angle that adds up to 180 with this. Whereas I kind of looked at like this triangle here and found that angle. So it doesn't specify which angle between the two sides, so it's just a different way of looking at that, and either way would be fine. The next one is 12b, and it says determine whether these points are collinear. So if we're looking to see if 3 points are collinear, remember that you want to know, are the vectors between them scalar multiples? So if we make two vectors, so is PQ a scalar multiple of QR? So that's what we want to show or determine. Are they scalar multiples? There's other ways of looking at that. You could also say, hey, what if I did PQ and PR? That would work. Or what if I did QR and PR. Whatever kind of combination of these that you want to do, that's totally fine. But I usually just do PQ, QR. So I'm going to find vector PQ, and just by subtracting the end minus the start. So 2 minus 1 is 1, 4 minus 2 is 2, and 6 minus 3 is 3. And then vector QR, -1 minus 2 is -3, -2 minus 4 is -6, and -3 minus 6 is -9. So then we do notice that this is a scalar multiple, that K, well, I guess it would go the other way around, that -3 PQ equals QR. So P, Q, and R are collinear. If you find a scalar multiple of one vector equals the other vector, then you know for sure that all of those 3 points are collinear.